The Earth's crust is formed of tectonic plates, which are like floating islands on the Earth's mantle. Sometimes these plates rub against each other, building up energy. When one of the two plates gets on top of the other, the energy is released and an earthquake occurs. This happened in Mexico on the 19th September 2017. Earthquakes themselves do not kill people. The constructions we build do, but it is possible to make our buildings earthquake resistant. A simple structure that looks like this would easily fail. To strengthen it, we can reinforce the connection points and introduce a truss system. Some design aspects that we should avoid include weak columns and strong beams, weak or flexible stories, hanging or floating columns, and discontinuous structural members. Above all, it is important for all buildings in earthquake-prone areas to be earthquake resistant. Although adding additional structures means more money needed to be spent, the cost is nothing compared to the rebuilding fee and also the loss of life. Earthquakes can have a severe impact on the soil and its slopes as they trigger landslides. Granular soil, such as the one on Luis del Naldo Avenue in Mexico City, is made of rough sediments instead of fines. In normal conditions, the maximum angle of a slope by granular soil is determined by the balancing forces of shear, weight, and friction. The angle of this slope is known as the repose angle. An earthquake disturbs the balance of forces in the slope. This causes the angle's stability to decrease. Therefore, any slope with an angle higher than angle stability fails. When the weight of a section of granular soil exceeds the frictional force between the soil layers, the section slides downwards. Therefore, a landslide occurs. In order to avoid landslides, engineers should design for slopes smaller than the angle stability by taking into account a certain factor of safety against earthquakes. Transport engineering is also an integral part of the earthquake disaster relief process. We need to get people out of crowded structures such as shopping malls, stadiums, and office places in the most effective way, using the least amount of time. Things we need to avoid when drafting evacuation routes are the mixing of cars and pedestrians in a road, conflicting pedestrian flows, or static crowds congesting the corridors and escape routes. The ideal exit plan is where the crowd moves in the same direction with proper signage, exiting at the closest exit following the flow of crowds. The route should lead to large open spaces where there is little risk of structural failure and accumulation of structural debris. Our role as civil engineers is not only to develop civilization, but also ensure the safety of it. In earthquake-prone areas, it is our duty to account for the prevention of earthquakes and disaster relief plans and build our structures accordingly. Only then can our civilization thrive under the harsh conditions of modern nature.